So, hello everyone. If you can see us, if you can hear us, set the thumbs up in the YouTube chat because we are about to start Cassandra Global Meetup with a special guest from Anken, Nanna's Einar's daughter. I'm doing my best, Nanna, to pronounce your last name. Not sure still if I'm doing that right. So,
nice effort.
okay, yeah. You know, people also always have problem with my last name, so I believe I know like how it feels. Good.
Yeah.
So, Michelle, would you say a word so I will know you are good with a sound?
Hey everybody, how you all
Yeah.
doing?
Okay, so we are good from the sound. Hi Ion, hi Timothy. And I see people are joining the talk already. That's amazing. So, that's a special day today because Cassandra Global Meetup doesn't happen daily. And that makes me smiling because I love those meetups. It's not the same like it was before COVID. So we were meeting in person with pizza and beers and live slides and live communication. Those were much better. But you know what? Whatever happens on the planet, we have to keep smiling, keep fighting, and doing our job well. So, first of all, I will ask our guests to introduce themselves. Nanna, would you please?
Yes, thank you. Hi, my name is Nanna Einarsdóttir. I am VP of Engineering at a company called Ankeri.
And what's this company about? What do you do?
We design solutions for the shipping industry, mainly to make easy all communication and information giving between two parties called a ship owner and a charterer. And I'll tell you more about it.
Okay, that sounds great and that sounds very interesting. Your talk today, Developer's Perspective on Apache Cassandra. You see, I believe what people making talks because they want to share some experience. What's the main experience you want to share with us today?
Well, it's the journey coming from a small team. I'm going to say unfamiliar to the non-relational world. It's a bit of do's and don'ts, which I've learned along the way that I wish that I would have known beforehand.
Okay, that's great. And our second guest today is a colleague of mine, Michelle Deroux. Would you please introduce yourself?
Sure. Thanks, Alex. Hi, Nana. Thanks for being here also. Really look forward to your talk. Hey, everybody. My name is Michel Deru. I'm a data architect here at DataStax, which means that I'm the technical lead for the region. In my case, region means the Netherlands and Scandinavia. And that's also how I got to know Nana. And I'm really excited that she's willing to share her experiences with us. On a more personal note, I live in the Netherlands, close to Amsterdam. So I would really love to have a physical meetup again in Amsterdam, like Alex said, with a beer and some pizza slice in your hand. And as soon as it's possible, you can be sure that I will organize one again.
Yeah, Amsterdam is beautiful, and you can definitely count on me attending or maybe even talking at the meetup. Yes.
That's already agreed.
Yeah, that's
That would be great.
absolutely have to go. And of course, Nana, we will be really happy to see you there. But you know what? Enough talking. Let's start sharing knowledge, and we will be talking, answering questions, and have some fun in the end. So, give me a second to prepare. Nana, could you please share your screen?
Yes.
And give me a moment to switch everything for us. And that's going to be boom, screen share.
How's that?
Give me a moment. Okay, so okay, you are good to go and your screen is live.
Great. So, like I mentioned, my company's name is Ankeri. And I'm going to tell you why we chose Apache Cassandra for our latest product and how our journey has been into the non-relational world. It's maybe not your typical expert talk, but it's a very real story and a useful one nonetheless. So a little background about me. I'm an electrical engineer and I graduated from the Technical University of Denmark in 2013. And I've been working and enjoying myself in the software development world ever since. I started out at a company called Marorka, where I was the lead developer. It's also a company in the maritime industry. I took a slight shift into sleep diagnostics in Nux Medical before I came back to the shipping industry by joining Ankeri in 2019. And on Ankeri, we are a startup software company. We launched our first product in 2018. And a little need to know about the industry where we work is that a company's shipping fleet usually consists of a combination of companies' own ships and ships that are chartered in, that is rented from other ship owners. And currently we have a variety of products out, all with the objective of providing a platform for the ship owner and charterer to communicate better and stay on top of fleet performance and potential chartering prospects. Which leads me on to our latest product and what this talk is about. It is our data connections hub. So we came across a certain problem of our customers. Like I say, their fleet consists of their own and chartered ships. Real-time data is recorded on board each ship using varied internal systems from different vendors. Then this data is made available on shore via a number of different APIs, and each providing the data in a different format. And then you have the problem of shipping coming and going from your fleet. So this can be very difficult to consolidate, both for monitoring and analytical purposes. So the solution is this data connections hub, which is an API, which serves the company's real-time data for their whole fleet. It is onboard system agnostic. It is data storage in the cloud, so the user won't have to collect any data on premise, and it's served via a single endpoint in a single configurable format. And along with it comes an administrative format where you can add and remove ships and users in a easy way. We developed this. We started developing this last year, and the status now is that we've launched a pilot phase with our first customer, and real-time data has been streaming in smoothly as of May. So, to give you our perspective, at the Takeoff, our resources were 4 people coding. We're a small company still. We have all the required business logic for the project, and we have good general software development skills. And we have vast experience managing databases, but only in the relational world. When it comes to the requirements of the product, due to the size of the team, we knew that it needed to be low maintenance. We needed good performance because the data is not only meant for analytics, but also monitoring, and also for providing data to our existing products. But we didn't only need performance, we needed performance that scaled. This solution should work as well for 100 ships as it should 10,000. These 3 points just shout out serverless to me. The last 2 points there. This is a new product. It's not a rewrite, and we needed a fast deployment of our minimum viable product to test the market. That's more to say that every book tells you to know all your access patterns before you dive into big data. But in some cases, it's impossible to know everything beforehand. So we needed some sort of agility in our solution. So we knew we wanted serverless. And the first answer you see when you start Googling is, of course, Amazon Web Services. So we chose Lambda and API Gateway to implement the API itself and the backend infrastructure. And this led to the very logical choice of Amazon DynamoDB as our database as a service. We wrote up all the access patterns that we anticipated at that point and came up with a decent design for a DynamoDB single table. I won't go into details on that, but the point here to make is that best practices for a DynamoDB design is to keep all your data in a single table, no matter what type of data you have. And just like that, we hit our first challenge. Our access patterns weren't set in stone. So as the product changed and as we found out some implementation details, we needed to modify and add new access patterns. And this meant a revisit to the whole DynamoDB table design. So this was limiting and slowing us down. And even though it was already October last year and pretty close to or closer than we would have liked to our internal deadline, we decided to switch databases. So we looked into Elasticsearch, MongoDB, and Cassandra, and we decided to go with Cassandra because of CQL and its familiarity, its similarity to SQL. The table structure with defined column names and types resonated well with our data structure. And then coming from this challenge, it was the ability to add new table for new access patterns. It's an easier step than to revolutionize your whole design. Then we chose DataStax as our service provider. That was due to high support level we received from the beginning. And that is also an important part of the criteria to me, because we knew that we couldn't know everything about this going in. And it would have actually been a complete waste of time to try to know everything. So you know what you need to know, and then you make sure you have good friends to help you with the rest. Once we had chosen DataStax and Astra for a serverless solution, we found out about an additional get out of jail free card, or it felt like that. That's the storage attached index. This can be a very comfortable solution if you already have a table out there. It has all the data you need. But you need to query by a column that isn't in your initial primary key, or it isn't your whole primary key. So for this table, ships, it's just a list of ships and all the available source APIs belonging to that ship. And we created this custom index you see in the bottom there, which enable us to also query the table by sources. So just to give you an overview, this is our all parts assembled solution. It's full stack serverless. And at this point, once we decided on Cassandra, the solution already looked like this, and this is our final design, even though we weren't done with hitting challenges. We had completed the initial setup. Our second challenge was that we assumed an unlimited number of columns per table. You know, you hear the term wide columnar storage and you stop listening, but maybe that time I should have listened a little bit further. So this is our main table, storing all the time series data from the ships. You can see our primary key containing the metadata for each data row. And then we have 25 data columns, and each measurement has its own column, one for latitude, another for longitude, etc. And this currently works great for our main access patterns. You can select all the data columns, or you can choose a handful. But the wrong assumption here is that we expected that we were able to add columns indefinitely as the product would grow and we would maybe move on to different market segments. But the fact is that in Cassandra, even though you select only by a couple of columns, the whole row gets read into memory. So if you have a couple hundred columns, all of them get read into memory, and this can slow the system down. And we probably wouldn't have found out about this anti-pattern that we had designed if it wasn't for Astra serverless guardrails, which is a set of rules or limitations depending on how you look at it. And one of them is that there is a hard limit of 75 columns per table. So this was a very valuable lesson for us to learn. You know, first I thought, this is silly, let's find a database provider that doesn't have this limit. But after some research, I found out that this was more a limit for my safety, not the databases, or maybe both of us. So our third challenge, this is more of a lookout warning. So we designed the partition key for our biggest table, this ship data table, very carefully. We made sure each ship had its own partition, and furthermore, we added a year as a bucketing feature to our partition key, so that the time series data would be bound to include only a single year for each partition. What we didn't think about, however, was the throughput that smaller tables might have. So as an example, each time we write data to the large table, ship data, an attribute in the table shown below, ships by source, gets updated. We update last data timestamp each time we write to the large table. And this means that even though it's a much smaller table, it gets a similar traffic as the other one. But for the table below, we didn't think to add ship ID to the partition key. And our backend system behaves the way that data is retrieved simultaneously for all ships for a particular source. So each time we updated the table for a single source, this small table got bombarded. So this was hard to spot. We had to put real load on the table before we found this out, but very easily fixed. We just need to add ship ID to the partition key. Our fourth challenge was that we were leaning too hard on the in operator. So this is our primary select statement, This is the select statement that's executed when the user makes a data request on the API. And what I want you to notice here is that we have 3 in operators. 2 of them, the one applying to year and source, those will never be, the items in these lists will only be a few due to the nature of the attributes. But ship ID, a company can have a few hundred ships. So there's a possibility that a user might ask for data for all their ships. And in that case, the in operator, who I now know is an inefficient one, would slow the query down. We found out about this one when we hit the 25 item hard limit of Astro guardrails, which was also a good thing to learn. This is also easy to implement in another way. Not exactly by changing, or not necessarily by changing the select statement, but more how the backend interprets the request from the user, or even by placing some limitations on the amount of ships the user can request, etc. But the point is that I'm not sure how we would have learned about this if it wasn't for the guardrails. We would probably just see random slow queries. It might have been hard to spot. This was the biggest challenge. It's an internal one. It's shifting your own mindset. It's a pretty hard thing to get used to, creating a data model from your access pattern instead of the nature of the data like you do in the relational world. Because the task is pretty laid out in front of you when you just create the data model from the behavior of the data. You usually have access to data before you even need to design every parts of your product. But having to focus on your access pattern first requires you to answer questions that you don't even know yet. Of course, when I look back on it now, it's more of homework that's also healthy to do when you're designing data modeling for the relational world. But yeah, it can be difficult to get used to. I felt the thought of denormalizing data was a bit uncomfortable. Duplicating data, like throughout your developer life, you may have had one rule, which is eliminate duplication, eliminate maintenance of data and code. So this is new. But if I think about it from another perspective of clean code, it's that it kind of takes weight away from complex queries that you see everywhere in code. And instead you have, yes, you have duplicate data, but you have tables named in a very descriptive way. And you have more maintenance related code, but that you can unit test. So it can be a comfort zone also. Another thing is that it's difficult to get used to prioritizing and limiting access pattern when it comes to your users. I don't know how many times I had the conversation with my product-facing team. I guess this access pattern really necessary? And the answer I got was always, it's better to have it. And that's usually that way. It's better to have all the options open. But in the non-relational world, you probably have to find some compromise. You can approach that compromise by getting used to denormalizing, saying more yes than no to your product-facing team. And then you can educate them about the sacrifices you have to make instead of all the possibilities that a powerful database like that gives you instead. So to summarize, for a small team of people, designing a new product and putting it out there, with primarily knowledge in the relational world, SQL, I would go for Cassandra because of the familiar table structure and CQL. It says, yes, know your access pattern beforehand, but adding an SIA can be your answer, or at least it can be a short stop before you need to duplicate your data. And adding a new access pattern in the form of a table doesn't require a revisit to the whole design. It's an easy step. It's available as a service and with a pay for what you use model. I say get your seatbelt on with Astra's guardrails. It's definitely a comfort zone for me. Of course, read up on how Cassandra works or whichever database you were using, but it is a certain comfort zone to know that you can't do whatever. Someone will stop you at some point. And it's learning possibilities. And then as a final note, make sure you have access to support and use it. So thank you for your time. And do you have any questions?
Okay, now you all can hear me, not only people in Zoom. First of all, I'm very sorry for people in Zoom. My bad. Meeting in Zoom started later when it was expected to be, and then had
Or maybe
some
I'll throw the
troubles.
ball over to you, Michelle, if
Sorry?
if
Oh,
there aren't any.
just a second.
Well, I think that probably there are,
Mhm.
but I think Alex has lost his voice.
Now I have to be fine.
Hello.
Hey, there we have you again.
Echo. Okay, that's amazing. Give me a second then.
Alex, do we have visibility on the chat windows? Are there any questions over there?
So I don't see any questions on Zoom, at least nothing seen to me, and on YouTube I see no particular questions. Okay, there is question. There is Ryan. You will see Shurya. You will see Ryan on Wednesday, and today is Tuesday, so don't be in a hurry. Now, Nana, thank you so much for your great talk. It was very interesting to me, especially one of the last slides about what the main challenge is to change the mindset. I do understand what you mean with some bloody tears in my eyes. It's always about changing mind shift in the end. Like that's really understandable to all of us.
Yeah.
Now,
Thought that might be the case.
okay, what I want to do now is I want to switch screen to the next talk done by Michelle. And Michelle, what are you going to talk about today?
So today I'm going to share a bit of information on cool new modern ways to connect to Cassandra. You know, I think most developers on Cassandra, they are used to working with a driver-based approach, writing some CQL in your client application. But we saw, I think the whole world has seen a rise of modern development stacks, where you like to integrate with REST APIs and talk through REST API to your persistence backend. So that is available on Cassandra now also, and that's something that I'll go and show you today. And if time permits, I might even throw in some bonus points and show some SAI indexing that Nana has been talking about. Because I think that the SAI indexes, they really provide relational scale index type of use cases for Cassandra. So it makes life very easy for developers.
Okay, sounds great, sounds very interesting to me. And if you would start sharing your screen in... or do you already? I have too many screens at once. Oh yeah, you are sharing already. Amazing, thank you. Then give me a moment to prepare us to see your screen. I'm
All right.
almost ready to switch to it. One now.
Just tell me when.
Yeah, just a second. Boom. Okay. So, you are live, your screen is live, and you can start.
Now for your nice presentation and the pitfalls that you fell into, but were able to get out of. So that was really nice to see. So yeah, let's go into some different ways of connecting to Cassandra. I know that Nana is using a driver-based connection, which is perfectly fine. It's a trusted way of connecting to Cassandra. But some organizations, they prefer an API-based approach using REST and GraphQL. And I will also share some information about using Cassandra as a document database. Yes, you're right, a document database. So we all know all these organizations. What I always tell people when they ask me at a birthday party, hey, what is it that you do? I also tell them that I work with the company that they interact with all day, every day. Because essentially when you wake up and you listen to some music to Spotify, you interact with the Cassandra backend. When you send out a parcel through DHL or FedEx, you interact with a Cassandra backend. When you send money to somebody else, you interact with Cassandra. When you watch a movie at night, you interact with the Cassandra backend. So I think that Cassandra has been accepted as one of the best scalable, fastest, and most reliable databases in the world. But like I said, it used to have a driver-based connection always. And that is something that now has been changed because, if you look here at the middle picture, you see that there is a way to interact with the database in any API and also in any data model. So what does that mean? Any API means that the REST API is available, GraphQL API is available, and any data model means that also document data is now a first-class citizen for Cassandra databases. So let's have a quick look here at this data architectural picture. Probably a lot of people will recognize something like this. On the top of the picture, you can see that it's all about developers. Because the developer in the end, they create the business value. And it's important for developers to work with the stacks, the development stacks that they like to use. So some of them are shown here on this picture. And then on the bottom, you see the infrastructures where people like their workloads to land, right? So here within DataStax, we really focus hard on Kubernetes because we think that Kubernetes gives a freedom of choice to you as an organization to run your data on AWS, on GCP, on Azure, even a mixture of those three, but also to run it on premises. Because Kubernetes is a standard that makes it possible to have a situation where you can migrate from one to the other. So of course, in the middle, this is what we will focus on today. Nana already talked quite a bit about the data store itself, and I'm going to focus on the level above it, which is the Stargate gateway. Because the Stargate gateway, that's the thing that allows you to work with all these modern APIs in Cassandra. So the way that it looks like, it's like this. You have your Cassandra cluster. In this picture, it's a token ring of some nodes. And the cluster can be anything. It can be DataStax Enterprise, but it can also be open source Cassandra. And it can also be Astra, our managed version of Cassandra, which Nana is using. And on top of that, we have the gateway. And actually, the gateway doesn't really sit on top of it, but it really becomes part of the token ring so that the gateway is aware of the topology of Cassandra and is also aware of the token ranges. And that means that it's not really a layer on top of it, but it's really integrated. And that's why the APIs are also quite fast. We see performance metrics, latencies in terms of 2-digit millisecond latencies on the lower level. So that's quite fast. And the Stargate API, the Stargate gateway, provides a lot of functionality. First of all, it's your connectivity gateway. But it also decouples the application from the database, because now the database nodes, they are responsible for storing the data, and the Stargate nodes, they're responsible for handling the query traffic, the query load. That also allows you to scale them separately. So it's really easy to separately scale out your database nodes and to scale out your Stargate nodes. Stargate does a lot more. It provides security, and it provides a familiar playground for developers using different types of APIs. So let's have a look at how it works. I'll quickly switch over to my Astra account, because that's the easiest way to demo the functionality to you. And I will just use my serverless database over here. Just to show you that I'm not cheating, I'm going to log into the CQL console. I'm going to use my serverless key space, and I'm going to describe my tables so that you can see that there's no table available that I'm going to use now. There is something available here, movies and TV, but I'm only going to use that if there is still time to show you some SAI indexes. So this is it. This is, so far for CQL. I'm not going to touch CQL anymore. Instead, I'm going to connect in a different way to the database. And the way that I'm going to connect to the database is using the REST API. Integrated in the Astra dashboard is a Swagger UI. So the Swagger UI is probably the easiest way to work with the REST endpoints. It's broken up into 3 sections. There's the documents section, which we're going to look at later on, the schema section, and the data section. For now, I'm just going to run a very simple query on the database, which returns all the key spaces. So this endpoint, the key spaces endpoint, I'm going to call. You can try it out here right from the user interface. And this is where I need to provide a token. The token is provides the security to the database. And the application token is something I can create in my dashboard. So for essentially every application that I want to create, I can create a token. So for now, I'm just going to generate an admin token. That's the easiest way to get this done. I'm going to paste that token here. Then I'm going to execute the call. And as you can see, these are the responses in a JSON format. Just make my screen a bit bigger. About the key spaces that I have in my database. And as you can see, this is the key space that I'm currently using. So the Swagger UI is very easy to try out some things and play around with. For the rest of the examples, I'm going to use Postman. So Postman is it's also a REST endpoint tool that you can just download and use to call endpoints. And first of all, I'm going to show you the REST API. The REST API is really tied to the wide row modeling capabilities of Cassandra. And as I said, the main advantage of it is you don't need your developers to really understand your CQL languages anymore. So also for developers that are less familiar to Cassandra, it opens up the power of Cassandra for them. And this example, I'm going to create a table. And essentially, the only thing I have to do to create a table is to provide column definitions where I define every column. And in this case, I define a column with a name of ID and a type is integer. The second part is the second column. So it's a column called first name with a type of text. So I'm going to call that. I'm going to send this information to the endpoint. This payload, this body payload is going to be sent to the database, and it provides me, returns a success is true. To show you that it works, I can go back to my database, log into the CQL console, and describe my tables again. And you will see that my second table is now also available. There we go. My table has been created. And let's describe the table. There we go. You can see that it has been created. There's an ID, a first name, and a last name. So that resembles my structure over here, the ID, the first name, and the last name, and the additional columns. So very easy, very simple, no CQL, just some JSON data sent to the endpoint. Now let's insert some data. And again, without using CQL, I only have to provide a payload where I say I have some columns, and the columns, they are defined as such. The ID field has to be filled with the value of 3. And the name field, the first name field has to be filled with the value of Joe, etc., etc. So let's call this towards the endpoint. And now again on the CQL console, if I select star from my table, Cyclist Semi-Pro, you can see that my data has nicely been inserted because I have an ID of 3, a first name of Joe, and a last name of Harwell. So it's very straightforward. Of course, I can also retrieve all the rows through the endpoint, through the API endpoint. For that, I'm going to call the rows endpoint. And here we go. I've got my data back, nicely structured in a JSON format. I can also run queries on top of the API endpoint. And in this case, I'm going to call the rows endpoint and add the query part to that. And the only thing I have to do is define a filter. So no real knowledge of CQL anymore, but just a filter definition where I say, hey, give me everything back where the ID equals the value of 3. And then I'm only interested in these column names. So not the whole table, but just these column names. So let's see what happens. And I nicely get back my JSON structure with the information from the database. So this is information, this is a bit of insight into the REST API. Now for the document API. The document API is a whole different thing, right? I mean, the big advantage of a document API is that you don't have to provide a schema upfront. You can just store any type of data, any arbitrarily complex JSON structure into a document database. And that is important for developers because it allows for more agility, a faster time to market. And still with Cassandra, you have the option to optimize your data model for the queries that you want to run, right? So, of course, a defined read optimized table will, of course, always be faster than a schemaless document API, right? So with Cassandra, you get the best of both worlds. The read optimized table to provide low latency queries and the document API to provide agility in your project. So let's assume this document, right? It's just a document, just an arbitrarily complex JSON document. And I want to store it in Cassandra. Normally, I would have to first create a table structure for it, but I'm not going to do that. I'm just going to send it to the endpoint. And while I send it, it is being stored in the Cassandra database. And it comes back with a document ID. So this is the document ID that is tied to this document. I can also create a document with a specific ID. Right? So here is the same document, but let's add something in here so that I can show you that it's really fully schemaless. And this is created when? Well, during the meetup. Oh, meetup. Here we go. There you go. Now let's send it to the database, and you will see. Oh, sorry, it's the wrong namespace. There we go. It is stored as with the document ID of 100. Now, if I want to retrieve my data, I can fetch all the documents in my collection. I'm going to call the collection endpoint, and I'm going to provide a page size of 5 because I don't want more than 5 results. And here we go. This is a nice JSON structure of the JSON data, the JSON document that I just stored. This is the first one with an ID of 100. And here we should see that it is indeed stored when? During the meetup. And this is the original where I didn't store that information about the meetup. Now, the nice thing about a document database is the fact that you can run ad hoc queries on the data, right? So I should be able to search on all of these fields, regardless of the type, regardless of the name, and regardless of the hierarchy. So that's what I'm going to do here with my query, because I'm going to search across the entire collection. And the only thing I have to do is I call the collections endpoint with a where clause that says game code equals I'm interested in hockey. There we go. There are 2 documents, and those are my original documents. Now, let's see. Yeah, here we go. Yeah, hockey. Oh, there's just 1 document. Okay, that's interesting. Let's see then. What did I create for the first document? Game code equals hockey. Oh wait, let's search on the meetup. Here we go. When equals meetup. And there we go. Now we have, nicely, we have 1 document based on the data that I just loaded into the database. So here are 2 examples. the REST API allows you to easily integrate with Cassandra based on REST API without prior knowledge of SQL. The document API allows you to use Cassandra as a document database with ad hoc querying. That's it for my part, unless, Alex, we have some additional time to show the SAI indexes, but I'm not sure for that. Let me know.
So I think actually this one should be over at what time? I'm a bit lost in time.
In 8 minutes.
In 8 minutes. We have to play a game. We have a quiz to run. We have a quiz to run.
More important.
Yeah, quiz is more important, sorry. I mean, we promised it, we have to do it within the time. But thank you so much for your talk. We have, actually, I believe it's not the last one. I had a great conversation with guys from Yelp. You know Yelp, I believe.
Mm-hmm.
And it was actually a very cool experience, what they shared. How do they use Stargate? Because they were using this approach for a long time. Yelp is big, they have a lot of developers, but they didn't want, they wanted to have all the benefits of Cassandra, but they didn't want to train every developer to use Cassandra query language. And also they didn't want to maintain multiple databases, but we wanted to have a single one, or at least not so many of them. And that's why they started to use this approach even before when Stargate happened to be. And it was a very interesting experience how they share it, how they use Stargate. A recording is still available on our DataStax developers YouTube channel. You can look for a Yelp and you will find it's a very interesting talk. I definitely recommend you if you are interested in optimization of a development process, especially for big companies, those have multiple developer teams, or for quite opposite small teams what want to use REST or GraphQL or document API, but don't want to lose the benefits of Cassandra. Those are great, obviously. So let me check something. First of all, let me check for the questions. And if we have any, I will read them aloud. I see a question which I can't open somehow. Zoom works quite weird to me today. Oh, no, this one is answered. Okay, and one is open. Oh, great question from Vera van Montfrance. I'm sorry if I read your last name wrong. Again, it's a day for me to pronounce things wrong. How viable would it be to have GraphQL language, GraphQL API be user front-end facing when it comes to document tenant user level authentication? Perhaps through some manner of API gateways? Or is this really designed just as a different way to access the database from a backend? I can send you this question if you give me a moment, so you will be able to read that on your own. And give me just 1 second. Okay. Here we go. Question goes to your chat.
Fireball will be
in Skype.
Yeah, sir. Okay, yeah, that's interesting. So I guess the question here is, how do we do user identity and access management to make sure that the right user is able to connect to GraphQL and then run queries on the right data tables? It is possible. So there are ways to automate this process. There is a DevOps API that is available for Astra, for instance. But you can also integrate with Stargate to make sure that the right users are being created, so that you can decide which user has access to which data. So that's possible. I'm just not sure if you want all your users to be able to run all the queries that they want, because it could also be the case that the user runs a query that is potentially harmful for a database. So in that sense, it might make sense to put something in front that checks for those kind of calls, because the assumption here is that, of course, a user, a developer, kind of know what they're doing. So yeah, it should be possible. Not sure if you want it. Also, would have to know a bit more about the use case.
Okay, that's great. So, I think we are about to start quiz. I'm switching your screen to my screen. That looks good to me. And now we maybe will need a little bit of music. Never hurts. And let me check the sound. We have sound issues, so I want double check what we all good. We good in Zoom. And we good on YouTube. Yeah, sweet. So we can proceed. Amazing. Yeah, even Mongo will hate you. Well, yes, document API make you able to work with documents without installing or working with Mongo. That's quite correct, yep. Okay, so now I believe we have some people today who never joined our quizzes before. And we welcome to see you. You need to know some rules. We ask you questions. You have to give the right answers, and you have to answer as fast as possible, because if you answer fast, you get more points and you have higher chances to win. If you ever won at one of our quizzes before, you are not you are allowed to participate, but you are not allowed to win the prize. So you are good to go. But if you take one of the first places, you have to move and reallocate your prize to the next one in the list. First 3 places win. Now, how do you join the game? Very easy, with the help of menti.com. Job is very simple. Go to menti.com. Easiest way to do it is to use your mobile phone. Just open menti.com and use the code 1979245 or scan the QR code next to me. It should be somewhere here. Good. I give you a moment to join and we will start. It's a short quiz. There won't be too many questions, but still some nice prizes. So go to menti.com, code 1979245 or use the QR code. I give you a few more seconds to join. I see we have a couple of dozens on people on YouTube today and some more people on Zoom. So I want everyone to be able to join. What's important? If you want to win, not just participate, watch your phone and watch your browser with Menti open, not the YouTube or not Zoom, because them, especially Zoom, especially YouTube, will have a little bit of a streaming delay, a second, maybe 2, in the question of a competition. That's a long time. So better watch your mobile phone. Questions will appear there immediately at the moment I push the button. Okay? So let me see how many people join us. Okay, if you joining, please set these thumbs up or set the heart so we will see what you joined. Okay, I see some people joined already and we are about to start. Don't forget, watch your phone or watch your browser, not the YouTube stream. I see 11 people there. I believe we can have more. So, where are my participants? Don't make that easy win. Okay, I have a bit more already, almost 20. Okay, one more person and we start. Okay, we have to go anyway. Now, final check on the sound. Okay, YouTube looks good. Zoom looks good. And it means what we have to start and let the battle commence. First question, and you have to answer fast to get more points. How many master nodes Cassandra needs? At least 3 per cluster. At least 3 per data center. Not a single one, Cassandra is masterless. Enough to maintain consistency. It was a short one, you have to be quick. Time is up. And most of you answered correctly. Not a single one, Cassandra is decentralized masterless database. There is no idea of a master or write replica in Cassandra. Therefore, first answer, at least 3. And last answer, enough to maintain consistency. Wrong. There is no master nodes in Cassandra. Okay, so who gave the right answer in the fastest way? Oh, Shivaguru Nathan. Nice to see him. That was the fastest answer with 931 points. That's a very good result. I see some familiar names. Hi Vera, I believe it was Vera who asked the question. I've missed it occasionally, I'm sorry. Hi Prasanna, hi Franz. Very well. So, a lot of things will change. We have more questions coming in. Answer fast to get more points. How data is distributed over nodes? With partitions. Full copy per node. Using address locators. By mail. So, how it goes? What's the right answer? Do you need to have experience with Cassandra? Oh yeah, that's Cassandra Global Meetup. So, time is up. Partitions, that was easy for you. Partitions, yes, not a full copy per nodes. Take a look, companies like Apple handles hundreds petabytes of data with Cassandra. Can you imagine making a full copy per node? With hundreds petabytes of data, it would be suboptimal solution at minimum, not to say worse. How it goes then? Who was the fastest? Most of you gave the right answer, but who was the fastest? TT was the fastest, getting to the second place with 1,861 points, and Marcel B overcomes the second place with 3 points difference. It's like 1 microsecond. Incredible competition. And that all brings Siva to the third place. Okay, and Mikhail is very close, getting ready to jump into the top 3. Let's move on. Question 3. Answer fast to get more points. How to scale up a Cassandra cluster? How to scale up a Cassandra cluster? Vertical scaling, upgrade server, increasing scaling factor. Horizontal scaling, add more nodes. We don't scale with Cassandra. So, how it goes? How it goes? What do you think? How it works? Hey, horizontal scaling, add more nodes. We prefer horizontal scaling over vertical scaling. It's more optimal for Cassandra. We don't increase scale factor because scale factor does not exist in Cassandra. And we don't scale is obviously the wrong answer. Cassandra is ready for any scale, and yes, we scale a lot. We love scaling. So, who was the fastest today and who made a mistake? Like, quite a competition. Derby was the fastest one, jumping into the top 10. That is a good result. Marcel B gets the first place, and TT is still on the second, with Konstantin overtaking Sivaguru Nathan and getting to the top 3. Michel is on the 5th place. Very, very well. And Prasanna gets higher and higher, slowly but smoothly. Very well. So, it's going to be question number 4, and you have to answer fast. What is recommended replication factor? Could it be 1.5, maybe 3, 15, or mostly probably 42? What do you think? What's the recommended replication factor? Per data center, if it matters. Time is up, and most of you gave the right answer. Recommended replication factor is 3. Not 1, not 15, not 42. It would be quite interesting, and definitely not 1.5. That's for sure. But let me see who made the mistake and who jumped into the list. Okay, so there are some changes. Dmitry was the fastest one. FMW jumped into the top 10. I see Pacman. I see Prasanna is already on the 6th place, which is great. And Marcel B, TT, and Konstantin are holding top 3. Now, many people wait you to make a mistake, guys. And that's a question number 5. Answer fast to get more points. Cassandra can be deployed on AWS only, any combination of cloud providers and on-premise, only one cloud provider simultaneously, Sega Mega Drive. So, what do you think? You have to think fast. And time is up. Correct answer is Cassandra can be simultaneously deployed on any combination of cloud providers and on-premise, and it will be exactly the same cluster, every node collaborating with every node. Not on one cloud provider simultaneously, not only one. You can have many of them. You can be truly multi-cloud, hybrid cloud at the same time. Okay, so looks like this one was easy, but who was fast and who was wrong? So looks like Q was a little bit slow this time, but still holding 8th place. And take a look, Konstantin and Dmitry get into the real competition, giving the answer in exactly the same millisecond. But Konstantin was faster in the previous questions, holding the 3rd place. And Dmitry follows him with approximately 70 points of a difference. That's not a lot. That's really not a lot. So tough fight goes in anyone can be in the top 3. So let's go. Let's go, and that's a question 6. We are getting closer to the end. Answer fast. Cassandra cluster can have multiple data centers. Yes, all DC active. Yes, part DC passive, read-only. Yes, but not more than 3 data centers DC. No, one cluster can only have 1 data center. So, your time is over. And most of you gave the right answer. Yes, you can have Cassandra cluster consisting of multiple data centers, all active. That's a native behavior. The idea of the passive data center doesn't exist in Cassandra. So, no mistakes again. It looks like Dmitry was faster a little bit, but TT was fastest, getting to the 1st place. Nice jump. Hey Marcel, there is someone who just overtake you, so you have to focus on, but the difference, ladies and gentlemen, is just 4 points. So that's again like really millisecond to millisecond. I can imagine how focused are you right now. And Dmitry still on the 4th one, but really close. And Prasanna is on the 6th. And hey, very nice to see you again in the leaderboard. That's good. So let's move on. And that's a question number 7. So answer fast to get more points. CAP theorem claims what in the case of emergency in a distributed system, consistency, availability, and partition tolerance all are reachable. Only availability is guaranteed. Only two of the three capabilities are reachable at the same time, or maybe we will need a new cat. We definitely will need a new one, but maybe later. And the right answer is only two of three capabilities are reachable. And yes, you need to have some knowledge of the distributed systems to be successful with Apache Cassandra or Astra. Well, with Astra, we will take care of it partially for you, but we still need to understand how distributed system works. So, yes, only two of three capabilities are reachable. Sorry, it's a real world. So, there were some mistakes, and it looks like we say goodbye to France, which I doubt will catch. Oh, no, he holds on the 9th place, but he's still on the leaderboard. Dmitry gives the fastest answer this time, jumping into the top 3, but there is no guarantees he will be able to hold on till the end. And Konstantin is on the 5th this time, and Prasanna is steady on the 6th. Very good job. Very well. So, that's the question number 8. And we have to answer fast to get more points. What is required in a Cassandra table? Data columns, clustering columns, partition keys. Nothing is required, everything is allowed. What is required in a Cassandra table? Data columns, clustering columns, partition keys. Time is up. And yeah, there is a distribution. I believe some of you like it, the last option, but the correct answer is partition keys. Clustering columns are optional, and data columns are optional as well, but partition keys are required for sure. So, are there any mistakes? Anyone losing his... Oh my god, Marcel! No! The leader just lost this question, getting to the 6th place. And like that's changed a lot. TT gets to the 1st place, Dmitry to the 2nd, and Sivaguranathan to the 3rd, with Konstantin really close to them on 4th, and Prasanna therefore on 5th. That was a surprise. And Pacman gives the fastest answer, getting to the top 10. Okay, that's getting interesting. Yeah, Marcel was too quick. I believe it was just too much in a hurry. Question number 9. Answer fast to get more points. Cassandra tables hold partitions, only rows and columns, replication factors, endless sea of dreams. What holds Cassandra table? What's inside? That may be a complex question if you don't have practical experience for sure. And the correct answer is partitions, not only rows and columns. And that's a principal mind shift you have to do to be successful with Cassandra. That's very important to understand. What? Table, partition, then columns. And partition is the base unit of access in Cassandra. If you think of a table as just rows and columns, your data model will be wrong and you cannot succeed. There will be problems in your database, big problems. Never forget about partitions. And I see 14 people made a mistake. Now please, we have Introduction to Apache Cassandra workshop twice per month, or at least once per month. You must sign up for our next Intro to Cassandra, or maybe Advanced Data Modeling with Apache Cassandra, which hopefully comes soon. And we will explain why it's so important to remember about partitions. And those 8 people who answered it, partitions, you are the best. So I expect a lot of changes. What will happen? Okay, that was quite a surprise. Of the leaderboard, only 3 people gave the right answer, which brings Dmitry to the 1st place with 8,303 points. TT still is on the 2nd. That was good overall performance, and Siva is on the 3rd. Okay, and some new names on the leaderboard as well. That's a question 10. 2 questions left. Let's start. Answer fast to get more points. How Cassandra executes joins. Joins need special join table. Exactly like in SQL, it doesn't execute joins. Executes, but kinda lazy. What do you think? What's the right answer? How Cassandra execute joins? I'm very curious. Okay, most of you gave the right answer. Cassandra does not execute joins with or without join table. It doesn't execute joins. Cassandra is a NoSQL database. There are no joins in Cassandra. And definitely not exactly like in SQL, that's for sure. So, what's going on in my leaderboard? Okay, no mistakes in the leaderboard, but definitely some differences in the answer time. Siva was the fastest this time, that's very good. Marcel overtakes Prasanna, bringing her to the 6th place back again. But there are no big changes in the top 3. So, what's going to happen now? That's a mystery for me. I know the question, but I know how you will make your answers. Now, breathe out. Breathe in, warm up your fingers, prepare, it's going to be last question. Last question defines everything. Here we go. Answer fast to get more points. Cluster has 8 servers in a single data center. How many servers you have to add to double performance? 4, 8, 12. Impossible to double performance within a single data center. 8 servers in a single DC. How many servers you have to up to double performance? Okay. And that's a very interesting outcome. Correct answer is 8. Considering your data model done right, by adding the same amount of servers you have right now, you are doubling your performance. Because decentralized and distributed, Cassandra maintains linear scalability, and basically, if you need to double your performance, you have to double your server count. Of course, we speak about perfect conditions when your data model is optimal. If you have any problems, that will not help, but I speak about the conditions when you follow it, our best rules for the best partition from the workshops we do for Apache Cassandra. Answer 4 would be amazing. It's amazing to double your performance by adding less servers than you have. I would love to have it, but again, in the real world, with no unicorns, it's not possible. And answer is impossible to double performance within a single DC is not right. Yes, it is possible. It's perfectly confirmed by Netflix. So, that was it. Maybe we are done? Oh no, we aren't done. You want to see the leaderboard, right? Okay, here is it. So, oh my god, Prasanna, Franz, I'm so sorry. That was a mistake. And that's how leaderboard looks in the end. Dmitry, first place with 10,182 points. Incredible result. TT, 9,917 points. Also, that's a very good performance. And Konstantin got to the 3rd place, overtaking Siva by some minor counts of points, like 200 only difference. And Marcel was a leader for a long time, but it's 5th place only, and the 3 first places are getting prizes. Now, Dmitry, Konstantin, and TT, you did really well. Please contact me, because usually I ask you to contact Jack Fryer, but he is on vacation this week. So please contact me on, I will publish my email, alexander.datastux.com. Yes, it's on YouTube. And I will publish it to Zoom as well. First 3 places, please make a screenshot of your prize position. And to panelists and attendees. Oops, panelists and attendees. Good. Alexander Voloshev, looks like no typos. send me an email with a screenshot of your first, second, or third position, and we will be good. What was the price? Price is some swag from DataStax. That's usually an Apache Cassandra t-shirt. I believe it was a glass or something. Actually, I'm sorry, usually Jack is responsible for prizes, but he's on vacation this week. And frankly speaking, I don't remember what's there besides the t-shirt. So, yeah. Yeah, Vera, come again next week. We run workshops weekly, sometimes even multiple times per week. And you will definitely get your chances. And actually, I see there is a couple of questions on Zoom, but I don't know what's going on with the Zoom. It can't open questions for me. I'm sorry, give me a moment to check something. I believe, okay, there is a question. This absolutely fun, great options in the answers. Thank you, yeah, I enjoyed it also as well. Okay, answer it, done. All questions are answered. It was a great day together with you, a great meetup. Thank you all for coming. Don't forget to subscribe to our YouTube channel or our workshop events at datastacks.com/workshops. We are done for today. It was an incredible day with you. And thanks a lot to our dearest... Oh, Nana, I see you joined us back. I didn't notice you enabled your camera. I'm sorry. So give me a second to bring all the speakers back to screen, because it would be really great to have you all. Well. And we are almost there. Okay.
The magic of 21st century technology.
Yeah, that's actually really cool. Can you imagine? You are located next to Amsterdam. Nonna, I don't remember. Where are you located, sorry?
I'm in Reykjavik, Iceland.
Yeah, and me in Germany. We used to have talks also from people in the United States. So that's how world works in the 21st century indeed. People from everywhere. And that's amazing. Let me check one more time for any questions. And I believe we are done for today. Right now working... Oh, okay. Right now working on the Academy courses. Planning to take up my dev certification this week or the next one. Eagerly looking forward. Not exactly a question, but thank you for saying that. First of all, I wish you all the best at your exam. And second of all, maybe you don't know. Cassandra is great. Cassandra is used in many of the biggest companies in the world, but world needs more qualified engineers. And that means
Definitely.
what we need more certified experts. Now, DataStax sponsors your education and certification, and you can pass your education. You can prepare at the academy.datastacks.com and get certified absolutely for free. And that's a normal, proctored, verifiable, globally recognized certification on Apache Cassandra done by DataStax. So contact me on Discord, YouTube, and so on. I will help you with that. And thank you for this message, and I wish you all the best at the exam, Shivan. Now I see John Pell having issues with Swag. I'm sorry, we indeed have problems with the logistics company who was sending it for us. So we will handle that later. Now, Nana, there is a question for you. Timothy asks, any performance statistics from Nana's project, please?
We don't have any performance statistics as of yet, but we're receiving on the broad spectrum. We're receiving data from around 250 ships currently, and we're hoping to be around maybe 1,000 next year. And that's we get a data package every 15 minutes from each ship. It's not exactly Internet of Things every second data, but it is really a lot when it all comes together. And it's being handled quite well by Cassandra currently.
You know what? Actually, I really like this question. It's right to the point. What are the numbers? Good engineers care about the numbers. And what I think it's actually a great idea to have next meetup. To have one more meetup, not next meetup necessarily, with you in half a year, in 6 months, let's say, and you will share like how this project advances and what's your new experience of that. That would be very interesting, and I believe a lot of people would be interested to see how it grows. And by the way, thank you for sharing. Not so many companies are as open as yours, so that's amazing to see these kind of data.
Yes, thanks a lot, Nana. Really appreciate it.
So thanks, for the platform, and this second talk you mentioned sounds really good. I'll gear up to it. Looking forward to it.
Okay, so I think we are done. I don't see more questions in Zoom. I don't see more questions on YouTube. It means what we are done for today. So thank you so much for joining. Sorry?
Thanks a lot, Alex, for organizing and being a great MC for Meetup.
Yeah, so thank you so much, and we are done. So this week workshop is Intro to NoSQL Databases, and it will happen tomorrow and on Thursday, 2 runs for different time zones, and we will be happy to see you there. And for the next Cassandra Global Meetup, stay tuned, we will publish the announcements very soon. We have a lot of interesting things coming on. So thank you. A little bit of music in the end, and see you later.
Bye, everyone.
Goodbye.
Bye, Nana.
Bye. Bye.